Hello and welcome to Math World. Today we're going to be transforming between slope-intercept form and standard form. This video goes out to Miss Brown, the geometry teacher. Now while this skill we will use and learn in Algebra 1, it'll be used in geometry a whole lot more. So I want to make sure that you have this skill and you're prepared for 8th grade as well. So what we're going to do here is we're going to be able to turn our slope-intercept form into standard form, or turn our standard form into slope-intercept form. And so just to recap, slope-intercept form is when we have our starting point, our intercept, and a single rate of change, slope. While standard form, we have our goal amount and our two rates of change that will work together and meet our goal. Now how can I turn one into the other? Well, we have our skill inverse operation that we will use for everything in algebra. So let's go ahead and see if we can use inverse operation to turn one to the other. Let's start with standard form. The goal is to make it look like slope-intercept form. Well, what do we notice about slope-intercept form? We notice that the x is on the other side of the equal sign versus standard form. So can we move this 3x to the other side of the equal sign? We sure can. Step 1, move the x variable to the other side of the equal sign. I'll subtract 3x because that's how you get rid of a positive 3x. I'll rewrite the problem. 4y equals, now I can't subtract 3 from 60 because they aren't like terms, so I'm just going to write 60 minus 3x. Look at this, it's already looking a little bit more like slope-intercept form. But slope-intercept form has no coefficient next to y. How can I get this 4 off of the y? Well, I can divide by 4, do the inverse of multiplication. Divide both sides by 4. Now here's the tricky part. That becomes y, that's easy, but the tricky part is when I divide this side of the equation by 4, I actually have to divide everything by 4. I kind of have to use distributive property even with division. I can't just divide the 60 and just divide the 3. When we divide this side of the equation, everything gets divided by 4. So what's 60 divided by 4? Well, that's 15. And negative 3x divided by 4? Well, we can't really do anything with x, so we'll just say 3 divided by 4. 3 over 4. And I'm going to leave it as a fraction, and it's actually going to be easier to leave it as a fraction than to change it to a decimal. And there we go. That's it. Let's look at this. Did it match? The only difference here is that I've kind of reversed the order. Instead of writing 15 minus 3/4 x, I wrote negative 3/4 x plus 15. I wrote it in slope-intercept form. So I did change it. Now let's see if we can go back the other way. Let's start with slope-intercept form. Well, in order to make it look like standard form, I need to get that x back with the y. So first thing I'll do, step 1, is add the x variable. I'm adding 3/4 x. Now, I won't always add. I'm only adding here because this is a negative slope here. If it was a positive, I would have to subtract. Alright, these cancel out. And over here, I now have 3/4 x plus y. I can't add it to y because they aren't like terms. And over here, I get my 15 is brought down. Alright, starting to look like standard form. Actually, technically it is in standard form right now. I have my x and y on the same side, and there's my goal amount. However, I don't like to leave them with fractions. It's a little bit tougher to graph if you have a fraction. So here's a trick to get rid of the fractions and make them whole numbers. All we have to do is multiply everything by the denominator of the fractions. So I'm going to do a times 4 here. Times 4. What happens is the 4's cancel out, and I'm left with 3x. But hey, there's a parentheses here, which means I need to distribute the 4 to both sides. 4 times y is 4y. So you see we have the 4 times 3/4 makes 3x, and 4 times y makes 4y. Now if I multiply this side of the equation by 4, I also have to multiply the other side of the equation by 4. 15 times 4 is 60. Hey, look at that. It turned into our standard form that we started with over here. So there's the trick. Use inverse operation and you can turn slope-intercept form into standard form and vice versa. Alright, now let's see if these two forms are indeed the exact same equation. We can prove this by putting them on the line. They should make the exact same line. So let's go ahead and graph slope-intercept form and standard form. I like to graph standard form first. It's a little easier for me. So let's find the intercepts. Let's make x0 to find my y-intercept. Okay, made x0, divide both sides by 4, and I get y is 15. So there's one of my intercepts. And so there's my intercept of 0 and 15. Alright, there's my y-intercept. Now let's find my x-intercept. Let's make y 0, cross it out, and solve for x. Divide both sides by 3, and I find that x equals 20. Alright, so there's my x-intercept, and I can graph it. X is 20, y is 0. And lastly, all I have to do to make this a line is connect the dots. There is my first line using standard form. Now, if this works, these are the exact same equation, it should be the exact same line for the slope-intercept form. Well, let's see. For slope-intercept form, we graph by starting by the intercept. Let's start at 15. Well, there's a good start. It's around the same dot. Next, we will use our rate of change, rise over run, to find the next plot. We'll have a rise of -3 and a run of 4. Let's see. Rise -3, 1, 2, 3, run 4. 1, 2, 3, 4. And look at that, we get our plot right on the line. If we continue this, going down 3 and over 4, we'll get the exact same line, plot by plot. So there you have it. These two lines are the exact same. These two equations are the exact same. We have transformed from slope-intercept form to standard form and vice versa, using our good old friend inverse operation. Well, that's it, and I'll see you in class. Now for a word from our sponsor, Papercut Games. This week's game, Hive. Now, Hive is called the new chess. It's called that because it's a two-player abstract game in which each player is going to get these little pieces that are actually bugs instead of chess pieces. And you'll see that they're different types of bugs, like a grasshopper, or an ant, or a beetle. But your main one, or your king, is the queen bee. Now, the way the game works is that each player is going to take turns putting their pieces onto the board. So you don't start with anything. So you put a piece onto the board, and they take turns. And the goal of the game is to surround the other person's queen bee. If you can surround their queen bee, you've won. Now this gets a little tougher to surround their queen bee because once the pieces are on the board, they can move. And just like in chess, they move different ways depending on what piece they are. The spider can move 3 spaces. The ant can move any space on the outside. The beetle can actually jump on top of pieces. The grasshopper can actually jump over pieces. And so you'll see there's different ways that the pieces can move, and the goal is to get the queen surrounded. And once someone's queen is surrounded, the game's over. So if you like chess, check out Hive. Pretty cool theme.